Okay, section 6.2, gradients. That means how slopey the line is. Now, look at the question up there. I've hijacked this directly from page 59. Gradients of straight lines. And you've done it in Key Stage 3 before. The steeper the line, the bigger the gradients. Now, what we need to do now is to be able to attach numbers to that gradient so we can calculate how big the gradient is, an indication of how steep the line is. Now, do you remember this from last year? I take maybe a red. The gradient is calculated by the height of the y section that you choose divided by the width of the x section. Now look at this. If I use a line here, maybe it will help me to do that. That's too thick. Take it down a notch. Right, look at that. From there to there, I've got 3 units high, and from there to there, I've got 1 unit. So let me just write it in for you. This is 3 units, yeah, from 0, 1, 2, 3. Here, from 1 to 2, I've got a unit of 1. So you may recall that the gradient equals the y part over the x part, and I've chosen 3 divided by 1, therefore the gradient is 3. Now, let me show you something else. Choose a different colour, blue. If I decide to go, oh, I don't know, large, and go, I don't want to ruin this bit, do I? Let's come down here. I go across 1. Oops, didn't draw the line, did I? So from 0 to minus 3, I've got a y part of 3, and from 0 to 1 is a width of 1. Straight away, look, I've got a gradient, you know, the y part divided by the x part, taken as length, so I've got a length of 3. Don't call that minus 3, it's still a distance of 3, so I've got 3 divided by a distance of 1. I still get 3, wherever I do it. If I wanted to take a huge, great, big triangle like that, I'll still get the same answer. Now, I'd like to use this again. Trouble is, I'm going to go over it in a different colour, so let's just go for green, and I will use the line function here. Now, look at this one. From here all the way down to here, and from there all the way across to there. Now, bear with me briefly. Can you see that from here all the way down to there, or from minus 3 up to 3, I've got 6 units? And can you see from 0 across here to 2, from 0 to 2, I've got 2 units. So using that part alone, the gradient's going to be the y height, or the y length, divided by the x length. Well, this time I chose a bigger triangle. It'll be 6 divided by 2. 6 divided by 2 is still 3. Therefore, however big the triangle is, whatever position you start with on the line, and whatever position you finish with on the line, you'd still get a right angled triangle, think of it that way, and you'll get exactly the same gradient. Look at all these little 3's we've got. They're all exactly the same. I could have done that anywhere. Now look at this one here. If you consider this something of a negative slope, this has a negative gradient. Think of it this way. It's a bit like thinking of a negative correlation. This one is a bit like thinking about a positive correlation. If it helps you to use that imagery, then this works. So this is a positive gradient. Please don't call it correlation in an exam. It's a gradient. It's a very definite relationship between the x and the y value. I don't know what equation that is. I'm not going to work it out yet. But that's definitely got a positive gradient. It slopes from left to right. And this one has a negative gradient, because it slopes from downwards from left to right. This goes up from left to right, okay? So negative gradient. You can tell it just slopes downwards. Right, let's just work out the gradient. So let's take my red, use my line function, just to show you I can go really large. Look at this. I want to go down here, stop there, and then go right across to there. Now, I've not done it perfectly, so forgive me. Right. From there to there, I've gone from minus 2 up to 1. Look at it. Minus 2, minus 1, 0 to 1. So the height of that line, if you like, is 3. Because from minus 2 up to 1, it's 3. And from minus 4 right along to 2, that is 6 units across. 6. So here's my gradient. Still going to be my y part divided by the x part. But you know the answer is going to be negative because it's sloping the other way. So just put a little minus there in case you forget. So I've got minus, the y part is 3 units high, divided by the x part, which is 6 units wide. Well, that's going to be minus a half. 3 over 6 is a half. Don't be frightened about having ugly little gradients like that. It's completely correct. Now let me try and demonstrate that this still works with a smaller little triangle. Let's go and use this now. We'll go blue. Look at this. If I start from here, I go 1 unit down, 2 units across. Alright? Let me label that in for you. In red, I've gone from this length here is from 0 down to -1. It's only 1 unit down, and from -2 to 0 is 2 units across. So what's the gradient? Going to be negative y over x, otherwise known as -1, all over a width of 2, and there it is straight away, minus a half. So it doesn't really matter where you draw it, just got to be really careful to count the squares carefully, to get the scale right in your mind, and to divide it appropriately. Please don't say 3 divided by 6 is 2. It's not, it's a half, and this gradient is negative. Alright, let's see if there's any more I can do there. Now I'm going to stop there just to introduce the way of finding the gradients of straight lines, whether they're positive gradients or negative gradients. I'm just happy to leave that. So you study that now, and I'll see you